Use logarithmic differentiation to find the derivative of y equals x to the sine x power. Alright, so now I do tell you to use logarithmic differentiation. Okay, can we use a power rule for this guy though? Right? So I mean we know, right? So for example, if y equals, let's say, x to the n power, then dy dx, right? We'll just bring down the n, then x to the n minus 1. Can we do that here? And the answer is no, right? Because it's not a number, right? It's another function, right? It's a composite function here. So we're going to use logarithmic differentiation. Now, actually, we'll do logarithmic differentiation. There's actually another method that we'll use, okay? So let's do that, right? Let's take the log of both sides, or the natural log of both sides, right? So we get ln of x sine x. In this case, we can use the power rule for logs, right? In this case, yes, we can actually just bring down that sine of x, right? So sine of x times ln of x. Now we can take the derivative of both sides. Okay, so when we take the derivative of both sides here, right? Once again, we're going to use implicit differentiation because that's a y term, right? So that's 1 over y, right? dy dx. But then what about the derivative of the right side? Well, we just use a product rule here, right? So let's see, okay, I guess we can do this on the side, right? So let's say we have these two functions, right? F times g, then the derivative will be f prime of g plus g prime of f. Okay, so let's take a look, right? The derivative of sine is cosine times ln of x, plus the derivative of ln of x is 1 over x times sine of x. And last step here, right? We'll just multiply back the y to both sides, right? So we get y times this whole thing, right? Cosine of x, ln of x, plus sine of x over x. And of course, we know what y is, right? So we can just put that back into the final answer. We get x to the sine x power, and then cosine of x, ln of x, plus sine of x over x. Once again, maybe do a little bit more simplification here. In this case, we can only just distribute this out, right? So yeah, I mean, yeah, this should be our final answer. Right, there's another method though that we can use, and the idea is, right, this x, right, x to the sine x power, right? It turns out that there is a rule we can use, right? X to the n power is actually equal to e to the n times ln of x, right? And this property may come in handy a couple times. Okay. So the idea here is, well, let's just do that, right? Let's convert this, right? So instead of taking x to the sine x power, right, we'll just rewrite this, right? Y equals x to the sine of x power. We'll just rewrite this as e to the sine of x ln of x. And then we can take the derivative of this guy, right? So what is the derivative of this guy here? Well, it's just an exponential function. So dy dx, right, is going to be just e to the sine x ln of x times what? Times the derivative of sine x ln of x, which we actually just done here, right? It's cosine of x ln of x plus sine of x over x, right? And if you take a look, these are actually just the same thing, right? What's in brackets is the same thing, and as I've given you this property here, right, these are just the same. Okay? I don't want to say one's easier than the other and one is more work than the other, okay? But knowing this property may come in handy. But of course, we can always use logarithmic differentiation as well. We get the same answer.